I should probably stand like...
You can stand wherever you
okay.
want.
All right. Okay.
Well, we're going to start a few minutes early. I'm Perry Cavalowitz, chair of the CS department. I'm joined by Professor Mahoney. For CS folk, we're basically almost all of the professors you've had, and we're very proud to have had you. In fact, this year's class represents the first four-year cycle for me. I'm very, very proud of everyone who's going to present today and next Tuesday and next Thursday. So without ado, I give you Andrew Henegahn with TrackPi.
Hello, my name is Andrew Henegahn, and today, as Perry mentioned, I will be going over my thesis project, which I titled TrackPi. To first start off the presentation, I'm just going to provide a brief overview as to what I'm going to be talking about today. First, I'm going to start out with a background, explaining how track workouts kind of work here, go into the problem definition and kind of where I saw an issue that could have a potential solution, kind of explain generally the solution that I have, go over a workout diagram to just kind of provide a visual as to how a workout in itself works as well, go over the physical components of what's actually in the boxes that you see in front of me today, and then I'll also move into a data flow diagram to show how the data flows and works from these buttons all the way to my coach's application. I will then get into my demo to demonstrate that it actually works, and then go over some reflections and just some takeaways that I learned from this year-long project. The background. How workouts are structured here at Carthage and just for cross-country workouts and track workouts as a whole is we are put into pace groups, and really all that means is you're grouped with athletes similar to your ability. So it wouldn't really make sense if the fastest athlete was paired with the slowest athlete. So that's really how those pace groups work. And at Carthage we have my 4 years here, it was 20 to 30 athletes, so we have around 5 to 6 groups. And then moving into group leaders, that's kind of the term that I coined them as, but we have around 1 or 2 athletes in those groups that kind of handle the timing. It's not a role that is even specifically assigned. It's something that just sort of indirectly comes about. So our coach, as I said, isn't going to say, hey, Drew, you're going to handle your group's timing today. It's something that I just kind of do, but that is what I dubbed as the group leader. So moving into the problem definition, the problem that I noticed, which kind of happened all the way back in cross country in the fall, but I saw that my coach had it was kind of a struggle for him to keep track of an entire team's workouts. So like I said, we have 20 to 30 athletes, and within those, they're running different paces, and even around track time, which is now, we have different event groups. So we have guys running the 800 meters, which is 2 laps around the track, versus the 10K, which is around 6 miles. So obviously those 2 different diverse athlete groups aren't going to be doing the same training. So within the different amount of abilities and different event groups, it's a lot for one person to handle. So I tried to come up with a way that could centralize it all in one place for my coach to make it easier for him. Moving into the solution, so what I have today is what I dubbed as TrackPi. This is a system that is solely Wi-Fi based and is something that requires user interaction, which for me is just pushing of the physical buttons. However, eventually where I want to go with this project is take it to a total off-campus experience. And what I mean by this XCPi is the eventual goal with this system is to use RFID technology to make it easier on the athletes to not have to worry about pushing the buttons, as well as more accurate timing. And for those of you that don't really know what RFID is, all it is the technology that you use to scan your IDs here at Carthage, or for marathon races and such, they have those chips that are usually behind the bib or on your shoe there. You run across these readers. The reader catches that time for that individual and sends the time up to a website where your loved ones, family, can see how you're doing in that race. So that's eventually where I wanted to take it, and that's something that I could definitely see myself kind of exploring in the future. So I'm going to explain just kind of a general workout diagram or a scenario, I guess I would rather say, to show you guys kind of how a example workout would run. So for the purpose of this workout, I decided to go with 300 meter repeats. It's not something that we do every time, but it's just an example that I thought would fit well with this presentation. One lap around the track is 400 meters. For 300-meter repeats, you'll start 100 meters in. Say I'm the group leader for the white group. I'm going to hit that white button, follow the arrows in the direction of travel, run that rep, cross the finish line, and then push the finish button there. And as I push the white start button, that'll send the timestamp data up to the database. And then once I finish the rep, I'll again push that button. It sends the data up to the database, and that's where the calculation is done. Now I'm going to be going over just some like physical components of that, the physical components that makes up the boxes that I have. The main driver for my boxes are Raspberry Pis, and for those that aren't familiar with what these are, they're small microcomputers that have Wi-Fi, Bluetooth, USB, Ethernet, everything that all the minimal features that a computer would come with today. And what I'm using these for is to communicate the button pushing all the way up to the database, and that has a Python script continually running as a service on them, and it is coded to read the button events as to when they're pushed, and that is what is driving the logging of the times. That also handles the time calculation on the end box as well. So that really is the main component of my project and what really makes it possible. I also have these big buttons, as you guys can see. They're connected to the Raspberry Pi via the GPIO pins, which I have a picture of what those look like later, but to kind of explain what those are, it's just general purpose input-output, and as I've kind of said, the Python scripts on the Pi have, they're coded to read when the input is spiked from like 0 voltage to 3, so all that spike is just when you push that button to start or stop the rep. And as you guys can tell, that is how the user interacts and run. That's my UI for this project, if you will. And then moving into the power source, it's just two external power bricks powering each Pi. And the purpose of that is I didn't want to have to rely on like a long extension cord, or anything like that. It was just something that could make these boxes more standalone. You can move them wherever the workout starts and stops for that day. So this is the picture I briefly talked about. This is just to provide a visual, this is the actual Raspberry Pi that I used for my start box there. These are the wires coming down from the buttons, which you guys can't see right now, but those stem down, plug into those GPIO pins, which are those sticking out right there, and that's how the whole system sort of works. And then this is just a general makeup, kind of a zoomed out view of the box. That's the power source plugging into the Pi, and then you have the buttons connected to the Raspberry Pi there. So now just sort of to explain how the data actually flows from those buttons all the way to the coach's iPhone app. It starts off with the athlete pushing any of the buttons corresponding to their group. It'll be registered. That button push will be registered by the Python scripts that are running. It communicates to the Firebase database via an API called Firebase, and that stores the starting and stopping data, and as well as the coach's phone has a iOS application running on it. I chose iOS because that is the phone that he currently has now, so for me it made sense to develop an iOS application for practicality's sakes, but he has a viewer on his iPhone that is constantly updating based on whenever a data point is added to my cloud database. So with that all being said, I will now go into my demo. Okay, so I'm gonna have I have this stopwatch up here just so you guys can kind of see. It's not going to be exact, but just so you guys can get a rough idea of the timing in terms of it like actually working correctly. And then this is the iOS app. It's run on an emulator for an iPhone 8. And then these are the groups. There's no data in my database right now, but once it starts to populate, these will be filled with that timing data. So I will now go to buttons. So push the blue group. It's like a 5-second delay. But as you guys could see, that blue start was registered, and there's nothing in here yet because the rep hasn't been completed yet. So all this is doing is, that's a timestamp converted to total seconds, and then this 1 represents that rep number since it's the first time or the first rep of that workout. I'll then finish the rep. It was around 21 seconds, which is roughly where that timer states. But once that finish button is pushed, it registers and calculates the time, sends it up as blue group, which is where the iPhone app knows to pull from. And that's populated there as it shows. And I'll do reps for the blue or the white and yellow button as well. I'll reset this. Around like 5 seconds or so, roughly, as I kind of said. But again, it shows the white and yellow start times. And just to show you guys that it actually works real time, I'll click on this yellow group here. Say for timing, it'll be around 20 seconds. So the white group correctly calculated. There might be a little bit of a lag with the network connectivity because I have been having issues with just the data being sent for all 3 buttons based on the network. But the general idea, I think you guys kind of get with just how the data is sent from those pies up to the database and then down to the coach's iOS device. So now I'm just going to kind of get into some technical takeaways. The big thing that I kind of learned from this project is to just read the documentation and how important that really is. So with all this hardware that I have in front of me, there was a lot of like requirements and specifications, like the amounts of power needed to actually power the devices and such, that I definitely would have saved me some time and money if I would have just been more diligent with reading those specs. And it was something that I definitely learned the hard way, just because I had to go back, buy like the actual part that I needed and all that. And then kind of going off of that, just I learned the importance of creating your own documentation. So with these 2 boxes being more or less the same in terms of their how they look and how they're made up and such, my idea was if I just simply configure one box to correctly work, the second box would be kind of a piece of cake in terms of just transferring the code and such over. But that wasn't the case at all. There's a lot of installations with the libraries and small things like that that I forgot, that I assumed I would just remember, but that definitely wasn't the case, and something that I would definitely take into the future if I ever were to start a project or take on a project of this size. And then more of like a personal reflection, it was very overwhelming initially. Just with everything you see there is all new to me. So I'd never done anything with Raspberry Pis or Firebase, or I've never even had like my own Mac. I had Windows growing up. So that, along with developing in Swift, which is the language for iOS applications, and then I actually built those boxes. So I even got into some woodworking. So yeah, it was all very new, and that kind of goes into my second point, where I didn't think I could do it at first. I remember walking out of Professor Kovalovich's office the first day with a box of various like wires and Raspberry Pis and stuff, kind of bug-eyed, like I don't even know what the heck this is, like where am I going to start, sort of thing. But that all kind of takes it back to the idea that we've heard a lot across our 4 years here, is just the importance of consistent work, in that how the general scope, yeah, it was scary for me at first, but I was surprised with how far I got in the actual project from December all the way through the end of February, just because I worked on it like an hour a day, 2 hours a day at a time, instead of pushing it off as I have done in the past and kind of cramming and such. I think for a project of this size, that was definitely a very good lesson, and I'm definitely happy that I followed that process. So that is my capstone project, and I would like to open it now for any questions. Yeah.
So for someone who's never used the Raspberry Pi before, what's the structure? Do you write code in just one file? Do you create classes? What is the kind of paradigm for programming a Pi?
Yeah, so I guess for setting it up, you have to flash the, I chose Raspbian OS. There's a lot of operating systems that you can choose to flash on, but once you have it flashed, I specifically just went into Python because that is a language that I've worked with in the past. I've done some like brief scripting projects and stuff, and that's really, I didn't make any classes or anything. It was just sort of a main with a bunch of functions, I guess. So maybe I could have explored going into more like an object-oriented approach, but I just kind of went into it and just made a script. There's only one file. It's just a .py script, and it just executes. So there isn't, as far as for my project, I didn't implement any class structure or anything.
So when the device starts up, it just runs this main function?
Yeah, so I have it set as a service. I actually had some issues. That was one of my big problems was how do I get this device or script to run headless, which is just without any monitor or anything, because it was running perfectly fine in the IDE, but I couldn't run it consistently well headless. And I eventually had to create a service which, an example of a service is like the dynamic host, DHCP, that's a service. So I really had to go to kind of like the lower level of things and create scripts to keep these things running continuously. And that was also like, I was having one issue too where my white box has, my white charging brick has two different inputs. One of them supplies a little bit more power than the other. And because of when these things boot, there's just like a lot going on and some inconsistencies. The buttons were being read as like they were being pushed because it was those pins were being reading. They were outputting spikes in voltage, but that was just from the computers themselves, like turning on and not from any interaction with the buttons. So I'd say definitely I had a lot more issues physically with more operating system stuff than creating like a class structure or anything like that. So, yeah.
What were some of the challenges using Swift and then developing the Swift for the first time?
Try to repeat the questions.
Yeah, so the question was what were some of the challenges with learning Swift and kind of doing that whole thing for the first time? This sounds, I don't know, strange. I'm not like tooting my own horn or anything, but I really didn't have any issues with developing a lot. The only problems that sort of came up, it's a lot like Python. So since I was working with that on my scripts, it was just kind of easy to adjust, and taking paradigms as well. That was just kind of learning all those different languages and stuff. I just followed the similar process that we did in that class. And it really wasn't all that difficult, but a lot of it was like dependency stuff. So like downloading the right libraries in order for it to communicate with the Firebase database. But in terms of like just starting from scratch and learning a new language and environment, it wasn't as bad as I thought it was going to be, which was pretty refreshing for sure. So go ahead.
What are some of the features and maybe, well, yeah, I guess what are just some of the features that you wanted to implement or were thinking about implementing or just didn't have time to implement solutions that you wish could have been part of the project?
Yeah, so the question was, what are some features that I wanted to implement, some of those want tos that I maybe didn't get to from the original spec? And I would say, I think personally for me, I really wish I could have kind of dove into the user interface of the app more. So I don't know if you guys remember, but the application itself is pretty stale. So I tried to look up any like Bootstrap or any kind of frameworks. So that's what I've done in my past classes to kind of just make it look more pretty than literally buttons on a web page. But I really didn't really have time to individually start out from scratch and craft each buttons to look cool. So I guess the only cool enhancement that I did is I made these buttons a lot bigger so you guys can see them. So, yeah. Any other questions? Yeah, go ahead, Mario.
How long would a Raspberry Pi last off that big battery you got there?
The question was how long would a Raspberry Pi last on the battery that I have? I left it running for 4 hours and it was still running completely. I don't know the exact runtime of how long it could be posted up, but it's definitely a lot longer than what hopefully any track workout would last for. So yeah, go ahead.
And then one more follow-up.
Hmm?
That's a really big battery. I've never seen that big. Do you know how many milliamps it has? Or
10,000? Yeah, 10,000. Yeah.
So since it's working, have you used it in a workout?
No, we have not. I wanted to test it during the indoor season, but that was when I was still implementing it. So it was actually kind of unfortunate. I really wanted to test. I'm more worried about the durability of the boxes. So like when we're finishing a rep, exactly, like you're tired and stuff, and I'm worried that they would have gotten smashed to pieces, and they are not my Raspberry Pis. So don't know if that risk was, but yeah, no, I didn't get to test them, unfortunately. So, any other questions? Cool. Thank you, guys.
Okay, we'll take a few minutes to set up the next speaker. Is that the lapel?
Yeah, I thought I could just leave it there. Or they could put it on if they want.
Oh, yeah. All right, will it work there? Oh, okay.
That's good. I put the microphone. I tried it from the back, and I just get too organized.
Thanks, guys.
Okay.
Thanks, Steve. Appreciate it. Thank you guys for coming. I appreciate it.